Hi, ladies and gentlemen. This is Mrs. Pullen. I'd like to go over example 4 from the 1.10 practice. Students in a large psychology class measured time in seconds. It took each of them to perform a certain task. The times were later converted to minutes. So we started off with data that was in terms of seconds, and we're going to convert to minutes. If a student's original z-score was 1.72 before the conversion, what was the z-score of the student after the conversion? And it turns out that the z-score would be the same. And the reason is that a z-score has no units. What do I mean by that? A z-score the formula is your data value minus the mean over the standard deviation. So suppose that our original information is in terms of seconds. So the data is in terms of seconds, the mean is in terms of seconds, and the standard deviation is in terms of seconds. That's going to reduce to 1, and so it has no units. So a z-score has no units. So if you convert everything in terms of minutes, you're still going to end up with minute minus minute, right? The data value is going to be in terms of minutes, the mean is going to be in terms of minutes, and the standard deviation is going to be in terms of minutes. And again, you're going to end up with a number that's going to give you a relative position, and so it doesn't matter the unit of the original data as long as you're converting each value the same, you're going to end up with the same z-score. That still may be difficult to understand, so I'm going to give you a set example. Suppose we have 3 people and we're going to measure their heights in terms of inches. One person 60 inches, one person 62 inches, and one person 64 inches. I calculate the sample mean to be 62, and I calculate the sample standard deviation to be 2. So now what I want to do is convert to centimeters. So centimeters, if I wanted to convert from inches to centimeters, I would take, there's 2.54 centimeters per inch, so you would just multiply each of these data values by x. And that's what I did in this column. So these are the heights of the original people in terms of centimeters. So now I want to calculate the z-score of the original data set in terms of the z-score of the original data set. So again, you're using the z-score formula, x minus the mean over the standard deviation. And when I do that, I get -1 for 60. I get 0 for 62, right? 62 minus 62 over 2 is just 0. Here I would get 64 minus 62 over 2, and that's just 1. So that's the z-score of the original data. So now I want to calculate the z-score for the centimeters. So I'm going to do the same thing. So I'm going to just calculate the mean and standard deviation. I entered it in the calculator. So I'm going to add a calculator page, and I'm going to hit Menu, Statistics, Stat Calculations. Whoop, that went too fast. Menu, Statistics, Stat Calculations, one variable statistics. I have one list, and instead of x, I'm going to use centimeters, and I get the mean of that distribution to be 157.48, and I get the standard deviation of that distribution to be 5.08. So let me write that down. So that was the mean of that distribution, so this is C bar or X bar, I guess you could still use X bar, is 157.48. And the standard deviation, Sx, was equal to, hold on, what did I get? 5.08. Oh no. And so now I'm going to calculate the z-score here. So it's the data value minus the mean over the standard deviation. And so when I do that, I get 152.4 minus 157.48 divided by 5.08. Turns out to be -1. 157.48 minus 157.48 divided by 1.08 is just 0. 162.56 minus 157.48 divided by 5.08 is equal to 1. And what you should notice is that you end up with the same z-scores. So again, a z-score is unitless. As long as you're making the same conversion to each of your data, you're going to end up with the same value.